Hi everyone, in previous class we were discussing about complex numbers. That complex numbers nothing but the numbers are of the form a plus ib. A plus ib, that a and b are real numbers and that I is called imaginary number, that value square root of minus 1. So here I equal to square root of minus 1. Then what is the value of I square? I square is minus of 1 and I cube equal to minus of I raised to 4 equal to 1. So on the basis of I square, I cube and I raised to 4, you can find I raised to 5, I raised to 6, I raised to 10, I raised to 99, whatever. So here I raised to 8, find the value of I raised to 8. I raised to 8 nothing but first here we have to write I raised to 4. Next 4 is here, 4 into 1 4, 4 into 2 8. I raised to 4 value 1, again 1 square value 1, so I raised to 8 value 1. If I want to find I raised to 15, I raised to 15, here first we have to write I raised to 4. Next adjustment, 4 is here, 4 into 1, 4 into 2, 4 into 3, 12, 4 into 3. Next remaining I cube, again 12 plus 3, 15. I raised to 4 value 1, I cube value minus of 1. So again 1 into minus 1, minus of 1. I raised to 15 value minus of 1. I raised to 24, I raised to 24. Again I raised to 4, 4 into 6, 24, 1 raised to 6, value 1. Here we have to solve some examples. So here first one, write the real and imaginary parts of the following complex numbers. Here first one is given 3 plus 5i. What is the question? Find real part and imaginary part. In the form of a plus ib, that a is called real part and b is called imaginary part. Here instead of a 3 is given, so real part is 3 and imaginary part I into b, instead of b given 5, imaginary part is 5. Similarly second one, what is the given? 4 minus of I in the form of a plus ib, that 4 is called real part and minus 1 is called imaginary part. Real part is 4, imaginary part is minus 1. Third one, here only given 3 times I in the form of a plus ib. A is not given. Not given means that value 0. Again we can write the third one, 0 plus 3 into I. 0 plus 3i, again nothing but 3i. In the form of a plus ib, real part is 0 and imaginary part is 3. Imaginary part is, so real part is 0, imaginary part is 0. Imaginary part is 3. Next, fourth one, 6 is given in the form of a plus ib, a value given, b value not given, means that b value 0. You can write in the form of a plus ib, 6 plus 0 into I. A value 6, b value 0. Real part is 6. Imaginary part is 0. So next, second example, if z1 equal to 2 plus I and Z2 equal to 3 plus 2i. Find Z1 plus Z2 and Z1 minus Z2. Here Z1 equal to 2 plus I and Z2 equal to 3 plus 2i. Two complex numbers given. That Z indicates, small z indicates complex number. First complex number, second complex number. What is the question? Z1 plus Z2. Addition of two complex number. Z1 plus Z2. Addition. Z1 is given 2 plus I plus Z2 value 3 plus 2I. Here we have to add real part and imaginary part. Real part is 2, here real part is 3. 3 plus 2, 5. Next, addition of imaginary part. Here 1 time, here 2 times, nothing but 3 times in the form of again A plus IB. That is a Z1 plus Z2. Similarly, you can find Z1 minus Z2. Here minus Z1 value 2 plus I minus Z2 value 3 plus 2I. 2 plus I, here minus of 3, minus into plus, again minus 2I. Minus 2 minus 3 minus 1. Minus 2 times I and plus 1 time I. Nothing but minus 1 time I. In the form of A plus IB. A value minus 1, B value minus of 1. Next one, evaluate 1 plus I into 1 minus of I. Multiplication of two complex numbers. First one, 1 plus I into 1 minus of I. Here first we have to calculate 1 into 1, 1. 1 into I here minus of I. Next, plus I into 1, I into I square, here minus of I square. 1 as it is, plus I minus I cancel. I square value minus of 1, here minus as it is. I square value minus of 1. 1 minus into minus plus 1. 1 plus 1, 2. In the form of A plus IB. A value 2, B value 0. 2 plus I into 0. Similarly, we have to solve second one. 1 plus I into minus of 2 plus 3I. Same. 1 into 2, here minus of 2. 1 into 3 times I. Minus 2 into I, minus of 2 times I into I square, here 3 I square. Minus 2 as it is. 3 times I minus 2 times I, again 1 time I. Plus I square value minus 1. Minus of 1. Minus of 2. Plus I, plus into minus of 3. Minus 2 minus 3 minus 5 plus I. In the form of A plus IB. A value minus 5 and B value 1. Next we have to solve on division method. Division method. Evaluate 1 divided by 4 plus 3i. 4 plus 3. Here we have to observe in denominator 4 plus 3 times I. Complex number is always in the form of A plus IB. In the form of A plus IB. In denominator, if I term appears, first we have to remove that I value. 1 divided by 4 plus 3i. Here rationalize, multiply and dividing by same term. Here plus, consider minus. 4 minus of 3 divided by 4 minus of 3. Suppose if it is minus, here we have to consider plus. 1 into 4, 4 minus of 3 times I divided by, in the form of a plus b into a minus b, nothing but a square minus b square. A square minus b square. 4 minus of 3i divided by 4 square value 16 minus 3 square value 9, I square value minus of 1. 4 minus of 3 into I divided by 16 minus into minus plus 9. 4 minus of 3i divided by 16 plus 9, 25. Next, this is equal to 4 divided by 25 minus of 3 into I divided by 25 in the form of a plus ib. That a value nothing but 4 divided by 25 and b value 3 divided by 25. So next one, evaluate 1 plus 2i divided by 3 minus 4i. Nothing but again division method. Here 1 plus 2i divided by 3 minus of 4i. Complex numbers is always in the form of a plus ib. If in denominator I term appears, first we have to remove that I value. So multiply and dividing by same number. 3, if it is minus, we have consider plus. Again same, 3 plus 4 into I. Next, multiplication. Here 1 plus 2 times I into 3 plus 4i. Here a minus b, a plus b, nothing but a square minus of b square. B square. 1 into 3, 3 plus 1 into 4, 4 times I. Next, 2 into 3, 6, 6 times I. Plus 2 into 4, 8, I into I square. 8 I square. Whole divided by 3 square value 9 minus 4 square value 16. I square value minus 1. 3 as it is plus 6 plus 4, 10. 10 into I square value minus 1. Here minus of 8. Whole divided by 9 minus into minus plus 16. So 3 minus of 8 minus 5 plus 10 times I whole divided by 9 plus 16, 25 in the form of a plus ib minus 5 by 25 one term and 10 by 25 one term. A value minus 5 by 25 and b value 10 divided by 25, or 5 is common here, 5 outside, here minus 1 plus 2 times again 5 into 1 5, 5 into 2 10, whole divided by 25. 5 ones are 5. So finally we will get minus 1 plus 2i whole divided by 5. A value minus 1 by 5 plus b value 2 by 5. Minus 1 by 5 plus 2 by 5 into I. So next one, if 4x plus I into 3x minus y is equal to 3 plus I into minus of 6. Here what is the question? Find x and y value. So x and y, here condition is given that equal condition, 3 plus I into minus of 6. So equal means real part equal to real part, imaginary part equal to imaginary part. Here real part is 4x. So here real part equal to 3. So x will nothing but x is equal to 3 divided by 4. X value. Next again, find the value of y. Imaginary part is equal to imaginary part. Here 3 times x minus y is equal to minus of 6. X value, 3 into x value, 3 divided by 4, minus y is equal to minus of 6. So here we have to find the value of y. 3 into 3, 9. 9 divided by 4. That minus 6. Minus is here. If it comes here, plus. Plus 6 is equal to plus y. Here LCM. 4 is here. 4 into 6, 24. 9 plus 24 divided by 4 is equal to y. Therefore, y value 24 plus 9. 33 divided by 4. X value 3 by 4 and y value 33 by 4. So next one is very important. Conjugate of complex number. Conjugate of complex number. If z equal to a plus ib is a complex number, then a minus ib is called its conjugate, and is denoted by z bar. Z equal to a plus ib. If I consider an example, z is equal to 5 plus 6i, then what is z bar? Z bar indicates conjugate of complex number. Here what is the condition? We have to change imaginary part sign. 5 as is the condition, we have to change the sign of imaginary part. Plus is here, consider minus of 6 times I. If z is equal to 6 plus 6 minus of 12, then what is z bar? Here minus is here, consider plus, that is a conjugate. If it is here minus, consider plus. If it is here plus, we can consider here minus. Z is equal to minus 2 minus 3i. Then z bar is equal to real part as it is, minus 2 as it is. Next, minus is here, consider plus. plus 3 times I. That is a conjugate. Next one, modulus of complex number. Modulus of complex number. If z equal to a plus ib, then modulus of z that indicates modulus of z is equal to under root of real part square, nothing but a square, plus next b value square. So modulus of z equal to square root of a square plus b square. If z is equal to 3 plus 4i, then find modulus of z. So modulus of z is equal to, again under root of first a square, a value 3 square, plus b value 4 square, 3 square value 9, 4 square value 16, 9 plus 16 25, under root of 25 means 5, modulus value 5. Here if I consider z is equal to minus 3 minus 4i, then modulus of z, modulus meaning we will get positive value, modulus of z is equal to again a square plus b square, b will nothing but minus 4 whole square, minus 3 square nothing but plus 9, plus minus 4 square plus 16, 16 plus 9 25, again under root of 25 5, that is the modulus of z. So z bar indicates conjugate of complex number, conjugate of complex number. And here modulus of z, that indicates modulus of complex number, modulus of complex number. Okay, we will continue next class.